In the next few slides, we'll look at how to assess the edge of the COMPA-15 mini-scleral. Once we've found the ideal vault, we have adequate clearance over all of the cornea. We now need to look at the edge profile. If the edges show impingement or vessel blanching, we need to order the lens edge with a flatter option. If the lens edges are lifting off or too loose, and we can see space or fluorescein underneath the edge of the lens, we need to order a steeper option. We can go 2 steps steeper or 2 steps flatter to adjust this edge. Assessing the edge is best done as the last thing before we remove the lens. So after the 60 minutes have settled, refract the patient, recheck central, mid-peripheral and limbal clearance, and then as a final step before lens removal, just gently push the lid onto the sclera just by the edge of the lens, as you can see in this picture. If it flares away very easily or is already lifting off, the edge is too flat. If it takes more pressure and the patient is aware of the pressure to get that sclera away from the lens edge, then the lens edge is too tight or the lens itself is too deep. Vessel blanching is also a very good indication that the lens edge is too tight. We would need to lift this off fairly significantly. And again, if you have access to OCT, we can use this to image the edge profile by getting the patient to look away from the midpoint and lining up the OCT on the edge of the lens. Ideally, we want the lens edge to be sitting approximately 50% into conjunctival thickness. Reverse geometry. We need to use reverse geometry on ideally sunken grafts and post-refractive surgery. Because we have this very flat central area while maintaining a normal profile in the mid-periphery, limbus and sclera. So this is technically called an oblate cornea. And we need to essentially think about this as 2 separate zones. When we put a lens onto oblated cornea, such as the patient on the left with radiokeratotomy, we have a very flat central portion. This creates a large amount of clearance centrally, and we can see the fluorescein pattern with the central air bubble in the image on the right. So we can now modify the COMPA-15 back surface by using reverse geometry. So this will maintain the correct relationship and clearance between the cornea and the lens. So depending on how flat the ablated area is, in the first instance try 5 diopters of reverse curve. If it's really heavy and there's a significant difference, then try 10 diopters. So the lens that we supply you will have a flattened back optic zone radius. This should eliminate the mid-peripheral bearing. It should bring the back of the lens much closer to the central cornea. Again, the power of the lens will be altered to compensate for this reverse curve, either by the technical department or by the use of the fitting app on the website. So this is how the fitting app looks. It does work on mobile devices. So you enter in the lens number that you're using, enter in your over refraction, what material you want to have the lens made out of, and colour. Any changes to the edge, any changes to the depth, any reverse curves that are needed, it will then calculate the lens that needs to be ordered, and you can send this to us either by email or just phone it through in the normal way. Some of the mini-sclerals that are available come with toric periphery. Part of the design remit for the COMPA-15 was not to need a toric periphery because the toricity of the sclera reduces the closer it is to the limbus. However, there are still some patients, particularly those high astigmats, where that toricity extends out into the sclera very close to the limbus. So we can create a front surface toric, and we'll put back surface toric periphery onto the edge to align with the scleral toricity. So we will send you a toric periphery lens with flat markings. If you then notate the rotational stability of that lens, the over-refraction and the cylindrical axis, Send us those details and then we'll be able to make you a lens with a front surface toric and a back surface toric periphery. This is also useful for patients who may have some lenticular or residual astigmatism. The lens generally is available in Optima Extra in either blue or clear. This gives us a DKOT of 100. As previously stated, we can range from 3,500 to 5,000 microns of sag. It is possible in extreme cases to exceed 5,000 microns of sag, but please speak to us in the technical department. Diameter is fixed at 15 millimeters, powers between plus and minus 25. No overnight wear is recommended with this lens, and we suggest that it's replaced on an annual basis. As far as caring for the lenses are concerned, the viscous comfort and conditioning solutions that tend to be used with RGPs are too viscous, and it's too difficult to get these off of the lens. Any of that viscous solution that adheres to the back surface of the lens when we insert it will particulate very quickly and cause visual problems for the patient. So we tend to recommend a soft lens multi-purpose solution such as Ote Sensation. A surface cleaner, preferably an alcohol-based cleaner such as Ote Clean or iClean, is recommended for patients who do need this extra cleaning step, perhaps if they're highly likely to deposit lipids, then this cleaner will be very good. All lenses are plasma coated as standard, so we recommend that you avoid abrasive cleaners. This will strip off the plasma treatment very quickly and decrease the wettability of the material. So, in summary, soft lens multipurpose solutions, alcohol cleaner if necessary, no abrasive cleaners, no viscous solutions. Thank you very much.